Continuous servo motors are a good choice for spinning the wheels of a car. Using the specialized for OD instructions, we can set the spin direction and speed of servo motors plugged in any of the 4 servo slots. In particular, the spin direction can be set either clockwise or counterclockwise, and the speed can be set from 0, which means that the servo is stopped, to 10, which is the maximum speed. Here we see a car, standing on the driver's left side. Therefore, we can see the left wheel. For the car to move forward, the left wheel must spin counterclockwise. We have now moved to the driver's right side. For the car to move forward, this wheel must spin clockwise. This table shows all the possible combinations of spin directions on both wheels, and the result of each combination to the car's movement. Let us build the robot for the first lesson. It is a car with 2 servo motors moving the wheels. All the parts needed to assemble this robot and any other part used in the lessons are either printed by you or included in the kit. We are first going to use animation in order to demonstrate the assembling task. We plug the left wheel into servo slot 1. And the right wheel into servo slot 4. And this is it. Let us now demonstrate the assembling task in reality. And now, let's program. We need to create 5 separate programs, each for a different movement, that is, forward, left turn, right turn, backward, and stop. Each separate program will run when a specific keyboard button is pressed. It is now time to set the spin of the wheels appropriately. Remember that the left wheel is servo 1, and the right wheel is servo 4. We will set the speed to maximum. Now we need to choose the exact keyboard button to press for each program to be executed. Move forward corresponds to up arrow. Move backward corresponds to down arrow. Turn left corresponds to left arrow. Turn right corresponds to right arrow. And finally stop corresponds to spacebar. Now we have to establish a connection between Snap for Arduino and ODI. We click on Arduino, connect Arduino, and choose the correct COM port. After a few seconds, Snap for Arduino establishes the connection. Then, ODI informs us of the established connection through a sound. Finally, we have to activate JavaScript extensions. We can now execute our programs. Let us now explain in simple terms how things work. On the left side, we have our computer, running Snap for Arduino. On the right side, we have ODI, and within ODI, there exists a program that runs forever, as long as power is on. This program is called Odysseus Firmata, and is a version of another program called Standard Firmata. Simply said, this code is a loop that searches for messages sent by the computer, and responds to these messages. The loop runs fast, that is, it is performed many times per second. But for the purpose of this demonstration, let us slow down time and see what is going on. As long as no message is sent to ODI by our program in Snap for Arduino, nothing is done. Then, at some point, we press left arrow. Let us now slow down time even more and see what happens. A message is sent from Snap for Arduino to ODI. When ODI checked for messages, the message box was empty. Therefore, the loop will be executed one more time with nothing happening. But when ODI checks again for messages, it finds the message in the message box. Then, when the code reaches the branch, it will go to the other direction, and act in order to comply to the message. That is, ODI will set the signal to the servo motors appropriately, so that they spin according to the desired direction and speed. And the loop will continue forever. We have now seen two basic notions of programming in general. The loop is a path of commands that is repeated over and over again. A branch creates two possible paths of commands, only one of which will be executed. You are now ready to play by solving these exercises. Let ODI move forward for a few seconds, enough to conclude if it goes straight. Does it go straight? Probably no. There is a reason for this. The reason is that the two servo motors are rarely identical. If it tends to turn right, we have to reduce speed to the left wheel, or increase speed to the right wheel. If, on the other hand, tends to turn left, we have to increase speed to the left wheel, or reduce speed to the right wheel. The command we used so far may not be accurate enough for this task. Instead, we can use the command shown here. If parameter refine is set to none, the command is identical to the one we already used, that is, parameters refine and value are not used at all. If parameter refine is set to upwards or downwards, we can achieve speeds like 8.1 or 6.8. See the examples to obtain a clear understanding of the new command. Now, with the new command, add two new moves to ODI. A straight forward move and a straight backward move. Another basic tool for programming a robot like Odie is the ability to freeze the program for a given time period. This is done through the wait command, seen here. Let us assume for example that we want Odie to move forward for 2 seconds, and then move backward for another 2 seconds. To do this, we set the servo motors for moving forward, and then we freeze the program for 2 seconds. When the 2 seconds pass, the program continues to the next commands, which will set the servo motors for moving backwards. Again, we will freeze the program for 2 seconds, allowing Odie to move backwards for 2 seconds. When the 2 seconds pass, we stop the servo motors. And now, some more practice or play. Can you do these exercises? Lesson 1 is over. However, keep in mind that up to now, Odie cannot sense its environment, and this fact allows for very limited games. New stuff in Lesson 2.